And we are live. Hello, everybody, once again. My name is Sanket, and I welcome you all into today's masterclass, which is going to be really interesting because we are going to go ahead and talk about data science in the gaming industry. Now, games have always been very close to a lot of cultures. We've been discussing about it before the webinar, also with a lot of participants already, and everybody seems to be very excited. And we are going to go ahead and talk more about it as I have somebody very special representing the gaming industry right now, from a data scientist's eye. I have with me Onkar Khati. Now, Onkar has been, has a tremendous gaming career, and he has worked on F2P and shooter games end to end, also Web3 games with stable economy. He works primarily towards data preparation, the database designing, game trigger environment classification, identifying parameters as well, and categorizing gameplay, outer loop, feature, design data, multiple things. He is a data science professional skilled with all the tools that more or less, that you, look forward to. And he's currently also pursuing his MS from Arizona University. So without further ado, let me go ahead and pass on the mic to him so that he can get the webinar kickstarted. Onkar, the mic is all yours.
So, hi guys, Omkar this side. Let's start with our today's webinar. So, it primarily focuses on the game data science. So, game data science unveiling the insights behind the game. So, designing the perfect game is not just about putting your frames, designing frames in place, but it is a whole lot of a big journey where developers create an conducive environment. The developers write that code to simulate your game to host that servers. Designers design your game, design the game economy as well. And finally, the process all ends up in the hands of data scientists or data professional to validate the designer's claims, to validate the feature engineering models deployed by the developers, and such keep on scaling these game. So yeah, we will also look into this more briefly as our subsequent slides. I am currently working as a data analyst at Super Gaming. So my career includes working for free-to-play games, Web3 game as well, and Battle Royale. To have a brief introduction about all of these categories is free-to-play games are basically categorized into the casual, hyper-casual games that you guys see around on Play Store or App Stores. So these games has an intention of just simulating with the player behaviors. I mean, to keep on increasing the engagement. Web3 game has a more sort of an economical angle attached with a game. By means the player here is just haven't downloaded your app just to having fun with the game, but he has a monetization angle as well. That is an earning source. Battle Royale is more into an hardcore gaming, where you see those games like Free Fire, PUBG. These are all Battle Royale games. So these have some hardcore gamers perspective as well. People who want to play a game as well, but they are not that as hardcore gamers and the casual gamers as well. So gaming data first is defined with what data to capture, I mean the data architecture as a whole process. So as compared with the services industry's data, like for example, any hyper casual app who sells an online items, say for example, Amazon. Amazon has a list of thousands of products on its website. So the more sort of data which we can collate with this industry is where order IDs, customer IDs, the products which they are interested into, the price range of the products, maybe the customer's age as well. But in gaming data, the user's data is just not sufficient. The user's metadata as such, the information about that data, that is metadata. So metadata is just not enough. You want to have the data about your game itself, like to validate the claims, how's your game working, how more you can scale up that game, plus the user's metadata as well, whether to identify whether the users who has actually downloaded your game, are they enjoying it? If they are enjoying it, are they converted into potential customers as well? If not, what are the strategies that you can bring onto the table so that you can finally convert those players into customers. So there are also different angles attached to it, like the automation. Automation it has a huge web in gaming industry. I mean, all the process needs to be automated. The process of capturing data from game, this needs to be automated. Now, storing this data into some databases, data warehouses, or data lakes, this also should be automated. Now, bringing this data from databases to analysis, that is, it requires some manipulation on this data. It also requires converting this data into meaningful insights. This whole pipeline needs to be automated so that the functionality and the insights grow smooth and hand to hand. Now, coming forward to our next slide is just the overview. So in this presentation, we will look how the game data actually looks like. What is the process to capture this data? First of all, identify this data, what all parameters are needed in a game data as such. Now to capture this data, process this data so that this looks clean into table and row formats. By table and row, I mean the data frames, the data matrices. Now data can be stored in multiple different ways. It can either be stored in a string, comma separated, as you know, as CSV files. It can be saved in a tabular format, what you generally see in Excel files, which is rows and columns. It can also be stored in documents. By documents, I mean the JavaScript or the MongoDBs which are in place around us. Like database stores one entity as one object. We will also look into the common applications of data science in gaming. Now, what are these common applications is this? What data science can actually enable us to find meaningful insights in the game and to optimize that game. Now, another thing is the data science techniques. Now, there can be a number of different techniques. For example, to prevent cheating in your game, you need to have AI bots in place. So these AI bots can identify potential cheaters in your game and can prevent your game economy and other players as well, so as to not disturb the player behavior or the player experience as such. Another data science techniques can we talk about is the churn rates. For example, a game has been launched, a hyper casual game has been launched by a company ABC recently. Just an hypothetical example. Now, this company has a very good installs as well, but this company doesn't have the retention. So their marketing team is performing very good. So they are bringing in the new players as well. But are there any issues in the game? So these players are not sticking around and they are not playing it regularly. They shouldn't just be converted into installs. They should actually be a day-to-day players as well. Now we will also talk about the brief concept which is outspoken in gaming industry, which is game analytics and game data science. We will also talk about the industrial applications, like how data science has helped some bigger games in making some fast moving decisions to scale their product as well, and to have a satisfying player behavior patterns as well. We will also lastly briefly speak about the career opportunities which you guys can focus upon to give yourself the head start in this journey. So moving on to next slide. So understanding the game data science. First, as the define says, applying data science techniques to analyze player behavior, optimize game design, and enhance player experience. So this is a very theoretical definition, but actually, if I were to give you just the real definition on what works in actual, is that making everything that can make your game run. That is the actual hardcore idea behind this. Like finding patterns in your data so that your game keeps on improving as a player base as well as a developed game as well. So significance of this is empowers developers and designers. Now let's understand briefly these two segments as well in gaming industry. So designers are those people who design your games. So these are the people who actually decide what feature to include in your game and what not. Considering an example of a simple car racing game, for example, most of you guys could have played Need for Speed in their early days. So Need for Speed was this a very good game in terms of design level. So what cars to show, what features these cars should have, these are all decided by the designers. So how much a race should run, how much by I mean the time, like a race should be of 10 minutes, 5 minutes. These all things are pre-decidedly designed by the designers. Now, based on this, yet developers create a layer of game. This layer of game is essential to actually process your game into reality. Designers draw these expectations on paper, developers actually convert this game on your devices. So another thing is with data science, we can also monitor the player engagement, monetizing strategies as well. Now, player engagement, as I said previously, is just not about getting installs. It's also about how your game works as such. Now, player engagement has an you can categorize player engagement into multiple different segments. So engagement is more of a qualitative aspect rather than a quantified aspect. By player engagement, I mean, has the user downloaded the app in the first place? Yes. Uh, how frequent is the user playing your app? How is retention on your app? Is he playing it daily or not? How to convert this user to play and engage with your game daily? What is his session time per day, per week, or per month? How much time per day does that user spends on your app? What are the strategies to increase that time? Because eventually the users who would be playing your game most would be paying you the most. So this all things has been easily driven so that a game is profitable. A game has a stable economy as well. So that players just not play your game, but they actually pay you as well so that you keep on making more and more interesting games around. Now, the key objectives in this gaming data science is also about to optimize the game features and mechanics. Now, if I were to give the example with the Need for Speed game only, so in Need for Speed game, say for example, a designer's expectation was that a match, a particular one race should prolong over 5 minutes. But as a data analyst, you guys come to know that no, data says that a match currently is happening just for 3 minutes. So there's a lag of this 2 minutes in your game in a match. So to cover up this match, so to cover up this lag, there needs to be a valid feature validation. You would validate the entire match duration feature. How would you validate that? You would segment your game or just a match map into different modes. Like what more time does user spends on a particular area of the game map? What are the different regions in the map where user spends less time? Now, as guys want to scale up the match time itself, you guys would focus on areas where user spends less time and would try to optimize these playable regions into more frequent playable regions. Now, another thing is the game performance. So, as an analyst or as a data person, you guys would hear this question repetitively that how is the product working? How is the game performing? Now, what are these benchmark criteria that you guys would relate with? So a game would perform eventually if the parameters are hitting your KPIs, if your key projections, if your parameters are hitting that. I mean, if your game was expected to be downloaded for 1 million installs, if it has hit that benchmark, yes, it is performing. If it is monetizing you on a daily basis, yes, it is performing. If you have good reviews around it, if gaming community is have an average or have a good overall rating about it, yes, your game is performing. There are also different steps involved in making these decisions. First is the capturing the data and storing it. Now, there are all different types of game as we discussed sometime before, like a free to play game, casual game, a shooter game. It could be a game related with any sports, like for example, FIFA, or it could simply be a puzzle game. Now, how to identify what all metrics are required so that you can make effective decision and you can store this data into databases as well. First is the player interactions. Now, for example, uh, how far the user is interacting with your game. Like what are the match modes in your game the player is selecting, how many times the user is logging in. So you need to store the data about the login features as well, sign up features as well. You guys need to store the data of the player movements as well. Now coming to the in-game transactions. So in-game transactions is the direct way where a player can be converted into a customer, where he actually pays for the, say for example, gold, any skin he purchases on the gaming platform, or any of the crates that he purchases, or he directly converts the real currency into the gold coins or into the gems of any particular game. Now the social interactions. Now social interactions data can only be retrieved from the social media channels. The most more popular social media channels for the gaming industry is the YouTube, where player actually play the games and make some random videos about it and they post it on their YouTube channel. Another could be Discord. Now, actually, we can have a sentiment analysis on YouTube data as well. So what we can do is we can just retrieve those videos with the YouTube data API. YouTube has this API feature as well, YouTube data API. So you can call these API features and you can get information about the videos which has been made on your game. Now we can deploy a sentiment analysis model on top of this YouTube videos, descriptions, comments to just get an insights on how your game is liked by the community or not. Now coming on to next part is the data collection methods. So there are different methods we use for the data collection. It really depends upon game to game. For example, if a game is very fast-paced game, say for example a shooter game like PUBG or BGMI or Free Fire or Garena, these are fast-paced game where actions and triggers are actually milliseconds away. They are very instantaneously spotted. So for this kind of games, we need to have a telemetry data in place where you actually get the real-time data of the player movements. Say, for example, a player death, a player moving in a particular direction, player picking up any rewards, player picking up any attachments, player picking up any good different features in your game. So this is the telemetry data collection method. Another is the game logs. So game log is basically triggered just after the event has taken place. For example, in a game like PUBG, an event could be a death, a player death. So player death is just not an instant. It is an action over multiple instances. So some another player could have started engaging in battle fires with the player for which the death has occurred. Now, during this time frame, you guys need to calculate the damage amount that the player one has potentially indicted upon the player two. So these all actions and triggers are stored in a logarithmic in logs manner, which is also game logs. Third thing is the databases. Now here are the RDBMS and the DBMS databases. Now RDBMS databases generally has the relations between different tables, and DBMS is a document type database. So a schema, a game schema, when you're designing what all parameters to include in a game, what all events to include in a game, you actually also analyze what is the use case behind using this data. Is it required to be stored in a document database format, or is it required in a relational database format? So this is basically the business case for which the answer really depends upon. Now, the importance of data quality. So I had very wise person at some time telling me like wrong. It's good to have no data at all rather than analyzing on wrong and false trends. So data should always be accurate. To maintain these layer of accuracy over the data, there's a whole different branch of validating the data as well, which is QA the data. As QA professionals test your game as well, they might test your data as well, whether this data is reliable to make business decisions or not. Now, to maintain the accuracy of the data, there are different checks need to be in place. First is the validation check. Now, the validation check is basically, for example, a damage amount, as we are discussing in the scenario of PUBG, a damage amount. Now, we know certain parameters intuitively and non-intuitively of this particular field. A damage amount, say for example, hypothetically can be in the range of 50 to 100. By I mean, it can be minimum 50, it can be maximum 100. So it can never cross 100, neither it can go low beyond 50, below 50. So any of these anomalies which you detect below 50 or above 100 are basically the outliers. So you need to identify these outliers so that they don't mix up with your whole data in your production databases, and they actually scrum all of your business decisions data. A complete and a consistent data is also important. Say, for example, I am designing a sign up flow for a login feature in my game. Now, sign up feature should actually assign a unique user ID to a unique user who is logging into the game. So no two users can be mapped upon the same ID. So this also requires a validation. As a data analyst or as a data professional, you need to monitor the user ID or player ID field as well. Are there any multiple IDs created? Are there any multiple users for the same ID? Just to maintain a sanity check on the data. Now, this part is the design, development, and QA. So, design is basically, as we discussed previously, designers first set their expectations that the game to be brought on the devices. Development is the developers who actually hard code everything for the designer's expectations, and the game is converted into a typical mobile PC or the console game. Now, QA is the top layer of those professionals who actually validate the designer's design and the development's output as well. They actually validate your game. They play the game. They try to find the bugs around it. They fix it. This is an iteration process which goes hand in hand as long as the game is in place. Now, coming on to the next topic is the applications. So, applications of game data science. Now, there are multiple applications of the game data science. As I have also worked in the services industry previously, so I was more sort of involved into grasping the user behavior to find the trends and the patterns. Who are your potential customers who can be converted into sales? Who are your whales, sharks? These are basically the technical terms, technical jargons being used for the players or the customers who can be converted into real purchases. So player behavior is not a quantified term. It is an qualitative term. You don't have any data in place where you could have in filled where this is a good player behavior, bad player behavior, or average player behavior. There nothing as such exists. These are the intuitions, or these are the analysis which you actually perform on different data and to conclude this player behavior as such. So there are different segments. Now, a player can be segmented into whole different categories. Is he a good player? Is he winning more matches? Is he an average player? Does he spend the average time? Is he a low rank player? I mean, does he lose more frequently? So you guys also should take note of those players as well who are not performing well. Because at the end of the day, the players who are not enjoying the game would also leave your game as such. So the players who are also losing much shouldn't feel like they are losing in terms of rewards. You should also make some patterns. You should also make some clustering so as these low end players should also get an opportunity of an competition so that they keep on engaging with your game as well. Now, another thing is predicting player churn. Predicting player churn is actually improving on your retention strategies. So you stop players leaving your game sooner. What are the different methods that we can do this? One thing is, uh, as taking me as a player, I would just end the game as soon as I have finished my match. But rewarding them at the end of the match would help me as such to stop the players for at least 3 to 5 seconds after match is ended. So these are different strategies which we adapt in your games so that we keep on increasing that session time, the player spending more time on the game itself or not. Another is the win predictions. So you actually pre-decidedly predict whether a user would win this game or not. So this is a prediction. This is not an intuition that you guys keep in place. Oh, this player has played most of the matches, so he has the most prediction to win this particular game. Things don't go around like that. You guys need to have an models in place. Oh, this player has a different strategy. He first at the initial time of the match, he plays in defensive mode. He doesn't expose himself much to his opponents. He has a whole different strategy as well. So a prediction. So a win prediction, a positive win prediction for that player. Now a debate of prediction and projection. Prediction versus projection. These two terms is the most, as far as the more confused term in the data science as of the game data as well. So predictions and projections. For projections, you might use the terms like forecasting. Okay, predictions, you need to analyze the historical data and find a pattern behind that trend. Projections, you don't care about the historical data. You just care about the future outcome. You just care about the forecasting, the end result as such. So prediction and projection does goes hand in hand, but there's a fundamental difference between these two. Predictions learn from the past data. Projection has an end goal of an future projections only. So now to talk about the game design optimization. So what is this game design optimization? Say, for example, in a car racing game where you find a player is spending less time in a match, a player, more of average player is just winning a match in 5 minutes. And you want this time to be increased to 8 minutes. And we are talking about a game, a car racing game as such. Now you will identify the patterns. What are the different positions in map? Now, if we analyze this whole scenario in terms of map, we will find the spots where players are actually taking lesser time to cover the distance. Cause in a car racing game, you need to have a distance, speed, and time metrics to be counted. Now, you will identify those areas where distance has been covered in a very short period of time. Now, as you guys want to increase the overall time by which overall time of the match, you guys would also increase the distance. You guys also increase the time for a particular distance which is covered. So it is a different case to case and business to business cases which we actually learn. Another thing is the tailoring in-game experiences for different player segments. Now, uh, there is no unified player behavior as such. A different player has a different expectations set forth with the game. So you have to actually briefly cluster these expectations and try to give an data-oriented output to it. Say, for example, a casual gamer. A casual gamer has just downloaded a multiplayer shooter game from an app store or an iOS store. Now, his intent is just to have a quick fun around the game and just casually play the game and to kill as much as opponents as he wishes. Now, converting this casual gamer into actually your potential regular gamer is this whole journey where the player behavior comes into place. You adopt different money. Yeah, yeah, John, there would be another 15 minutes for the Q&A. You guys can post any doubts if you have upon this slide. I will try to pick it up in the subsequent sections as well, or in the Q&A as a whole. So another application, if you speak, is the monetization strategy. Now, analyzing the spending patterns, uh, like, am I getting huge revenue on weekends? This might be the reason where school and college students has their typical weekends off and they play more and they convert more. Am I seeing any particular pattern just at the initial launch of my game? Am I seeing any particular pattern actually at the night time, actually in the daytime? So these are the different clustering approaches that we guys decide upon so that we can adapt the monetization strategies as well. Another is the optimize in-game purchases. So what is it real about? To not really bother your player for purchases and advertisements so much that he will attend, frustrate, and leave your game as such. So marketing or monetization or player behavior or targeting your player for better enhancements, better progressions shouldn't come at the cost of player experience as such. Player experience is mean your player base. Another is the personalization offers. Once you have the clustering models in place, you can have more personalization offers as well. As in, a pair, different. If you have a different cluster of players, low end players, medium end players, and the high end players. So a player who on typical pays you $1 per month on average. So there would be no meaning showing this player an offer of around $1,000. He won't buy it because he don't has that pattern. He don't has that buying capabilities as well. So getting more customized offers for these players as well. So another is the techniques that are used in gaming data science. Now, I have personally learned this very couple of years back. This was from my Google data certification. So it was a very important and vital steps in the data analysis journey. It was the ask, prepare, process, organize, share, and act. As in data analysis, the first step is you should ask questions. What analysis is needed? Why is it needed? What is the intent of that analysis? What goals are we achieving with that analysis? Second is the prepare. Prepare yourself to answer the questions. I mean, data wise. Prepare your data sources, prepare your databases, prepare your research documents. Now process this. Now bring that data from your preparation stage to process stage. I mean, get your hands dirty, work on that data, process stage. Now comes the organization stage, where we actually organize the all the manipulated data into a structured data where it can be into human readable format, where you can drive insights from those data. That is showing these insights into pie charts, good line charts, showing it on geographical maps as well. And another is the act, which is just acting on your intuitions and acting on your data trend lines. So first is the DVA and descriptive analysis. DVA is the data visualization and analysis. So there are a whole bunch of tools available for it. If it is an RDB MS database structure, you can always have an SQL database in place. To visualize the data, you do it on any BI tools as such. Python has also some good libraries around it, like Seaborn, Matplotlib, Dash. Another is the predictive modeling. So predictive modeling is actually used to validate your features as well. So uh, say, for example, a designer in a car racing game has introduced a new car, which actually runs more than a 200 kilometer per hour as compared to the other cars. So this new branded car has really an interesting feature that it can win you a game. So you have to validate this feature. Is this feature valid? Will this introducing a feature will distort my whole game economy as such? So these are some of the trend lines. These are some of the patterns that should also be accounted into the predictive modeling picture. So modeling is just not about working on the data. It is also a bit about getting to know about the right assumptions as well. A/B testing platform. What is A/B testing? A/B testing is just comparing two features as such, uh, validating two hypotheses, validating two features, anomalies, spatial analytics. Now, spatial analytics can be imagined on a 2D or 3D surface on a map. Spatial is geographically spatial or non-geographically spatial. So geographically spatial is our geo globe, and non-geospatial is the game virtual map. Say, for example, NFS or FIFA has a map. For a map for a FIFA would be a field, football field as a whole. So actually plotting the movements as well, plotting the in a shooter game, plotting your actually players on the map, seeing them move around the map, gather insights on what portion of the map player actually doesn't prefer to go much. What is the portion of the map where the most heat is upon, where players land the most, where players engage the most, and they firefight the most. Next is the supervised and unsupervised learning. So these are all some of the machine learning terminologies here. Supervised and unsupervised learning are the model training efforts, which you guys bring for the model evaluation, or the anti-cheat codes that you guys keep in place. Next is the clustering methods and sequence analysis. So clustering methods, as we talked about, has a huge business case of clustering players into high paying, low paying, clustering players into good players, bad players, average player, uh, clustering damages, clustering hits, clustering purchases on the basis of month, year, or even days, or even weekends. Neural networks and AI models. AI models, so understand this terminology. Data science as a whole also contains about a bit of an AI in term. So deploy an AI model. There could be the cases where you have to deploy the AI model to prevent cheating on your game, to actually keep bots in your game so that there's a good player engagement as well. So players don't feel left and empty out in the game map itself. So I guess we are running short of time, but uh, case studies. So we'll look at some 2 to 3 random case studies. Uh, Say, for example, the objective of the first case study is to optimize in-game advertising and promotions, segment player based on behaviors and preferences. So objective highlights that you have to segment players based on their behaviors and preferences. And another objective is to optimize the in-game advertising and promotions. What do you mean optimizing? To improve it, basically. So you have to improve the game advertising so that the advertisements are not too much frequent to bother your players, and then eventually increase their churn rate. Basically, you have to balance your advertisements in a way that players don't feel much frustrated as well, and you as an uh, data person or then team who is running the game, for them ad is profitable as well. So first comes the data collection processing. So you need to collect different data for these games, like what ads users are seeing the most. How should there be targeted advertisement? What ad should be basically people should show, people should see more, and the behavior and preferences as well. So modeling. So in modeling, you have to actually cluster the algorithms to group players into segments based on their behaviors. There are different modeling architectures in place around this, and clustering is a field which is still in place. So you always have to cluster your data. You always have to cluster your models so that there is a high-end optimization in the data architecture as well. So what all things we can intuit by seeing the objective. We can easily see that players can be segmented into casual players, competitive players, and the spenders. Spenders is the monetization angle of that player. We can have a tailored marketing strategies in place as well, so that there are more in-game offers for the players who pay you regularly. There are low offers for the players who don't pay you regularly, but the end goal is to convert this player into a potential huge monetization base as well. First objective was more sort of related with the player behavior and the segmentation as such. Objective two will more sort of deal with the technical aspects of the game design. As objective two itself says, to enhance the gameplay experience and competitiveness, aim to balance the game. So it's more about to balance the game. There might be the case where a game is launched, but initially it is not being liked by the players much. So you need to optimize this trend. You need to optimize your game to match the players' expectations. You need to improve your game. You need to scale up the game. So there are different targeted strategies for this. Now, data collection and processing is the essential part which comes in. Now, we use the statistical analysis. So what is the statistical analysis more about? You try to find the average time a player spends in a game, average time player spends in a day. Now, to improve these, you have to improve your gameplay metrics as well. Another is the sentiment analysis. As we discussed sometime before, we can have a sentiment analysis on our game, how our game has been looked upon the co-players, how it has been looked by the community, and then taking the feedbacks and improving upon them. So the outcome for this process is the improve the retention, improve your player base. Because after all, a good player base will give you a good game. A good game will give you a good monetization. So this is the feature engineering. So in a game, each design basically a major portion of the game or a major event in a game is a different feature altogether. If you guys can correlate with the example of the PUBG, a vehicle in a PUBG is a feature. A circle in a PUBG is a feature. Dead zone in a PUBG is also a feature. So feature are these really different cool aspects of the game which designers add upon so as to increase the player behavior, player randomization, to increase the player engagement as well. Okay. Now, another example is to predict the player churn in an online game. By player churn, I mean the player who has already left your game, who are not playing it that regularly as compared to the different churn patterns. So to understand the player churn, you need to understand how frequently he logs into your game. So you need to have the login and sign up data in place as well. So as to understand his login frequency. You need to understand how recurring he is paying the game, what social interaction he has in the game. Each game has this social interaction click-ons, like share it with your friends on Facebook, share it with your friends on Instagram, on Twitter. These are the social interaction frequency. The player who opts to hit these triggers, who opts to hit these buttons, are the ones who are more socially interactive with this game as compared to their co-players. So also making strategies to enable these co-players to explore the social interaction features in your game as well. Because it is the easy source of publicity and easy source where you can take your organic players into account. Now you can also have an machine learning models in your place. So machine learning models to just tell you what would be a churn pattern. So a model learned a huge terabytes of data on a good system. Uh, the an input data would consist of an login times, player IDs, how session lengths, and session frequency. So machine has an huge amount of data to learn from the player behavior, player signups. Based on this input data, you actually need to design a whole process where the end goal is this, where the end goal is where the machine can where the machine can actually predict the churn pattern for any user across your game. So outcome for this could be an implemented targeted retention strategies for at-risk players. By at-risk players, I mean the users who are more potential to leave your game. So you can have a more targeted approach in place. So you can actually retain this player base as well, and add a more player lifetime value. So different career opportunities in gaming world. So honestly, guys, gaming as such is a whole more web of job opportunities in data field as well. Like game analytics and game data science are these two terms which has been outspoken lately very much. Game analytics more sort of deals with the insights which have been put in place, insights which you guys bring on the table so that the game engages more with the player. Game data science is actually to optimize the game, to optimize the player behavior so that the business end goals and the business decisions are made. Gameplay analytics. Now there are a whole lot of different bunch of people who just analyze on the gameplay data which gets captured. So, for example, a shooter game captures more about the weapons, captures more about the bullets fired. So you can analyze this data and have an really cool insights on the place as well. Now, business or the data analyst analyze the usual trends in the game outer loop. Outer loop, I mean basically the metadata about the players, like it can be how much skin does the player has got in a reset time, how well the pair the player actually is. Game data engineer actually who designs the backend, who designs the database, who designs the database schema, to define the game events, to define the cluster, the game parameters as well. Data scientist, data modeling, these are all the good career opportunities which are actually high in demand as the gaming career is being getting up. Feature engineering, data architect as well. So yeah, let's open this up for the Q&A, question and answers.
Thank you, Onkar. Thank you for this exciting session. I was looking very closely at what was being explained. It was really exciting. And I hope our participants also enjoyed this. Having said that, I've already given all of you a form also to fill in. There is something that you guys can fill in if you are interested in enrolling into any of our programs. There is some exciting offers that are in place. I've already mentioned it to you in the chat also. So you can go ahead and look at it, and you can also go ahead and, let us know if you have any question, anything as such. Having said that, guys, now, if there's any question that anybody has, do let me know. It's a paid course, Joseph. We don't have, it's not free courses. These are all paid courses, but there are offers that are available with it. All right. Thank you once again, guys, for being a part of this session. I hope you guys really enjoyed it. Now, any one of you have any question, just let me know. All right. So Onkar, we are getting a few questions. Let's try to take them one after the other. Let me see. So Catherine has a question. I am now working as a research analyst. Which steps do I start to get in game? So, okay. So how does somebody get into the gaming industry?
So it's more about that you learn about the technical hard data stuff first, like to get to know about the SQL databases, get to know about the advanced Excel, learn about the BI tool. I also understand that gaming data is far different from the product data, which you guys usually see upon. So understand what are the requirements that the game has, what all data that the game captures. It also has the user data as well. It also has the game data. So game also has its own concurrent data, which is what kind of game it is. It is a racing game. So it's a racing game. It could have more cars about it. It's a shooter game. It has weapons in it. It's a shooter game. It could have damages. It could have health as well. If it's a car game, it's about speed. It's about distance. It's about time. So there are some intuitions as well. Plus, there are some game specific data points as well. But the most essential part is the data skills or the data tools that you guys learn about.
Right, great. Any more question, guys? Can we access the recording? How to access? I missed the first 15 minutes. Well, it's on our YouTube channel. So if you go to Zoltius YouTube, you will find it over there. How long does it take to learn most fundamental up to advanced skill knowledge in game data analytics? Juan has this question. Juan Paulo Ruiz. Onkar, would you like to take it?
Yeah, so Joanne, I would just advise you to focus on the basics analytics skill, which I have discussed sometime before. And I'm sure with Zaltius, you can also explore some of the good their upskilling programs as well about the SQL, about the BI tools as well. So you land up into more opportunities, you have more skills in your pocket as well to grab those opportunities. But on an average, 5 to 6 months down the line should be more than enough to have a general overview about the whole domain.
Yep. And having said that, it's not about the time, it's how many hours that you actually are able to dedicate in that time also.
Actually,
So
quality
that's
time. Yeah.
that's very important. I know people who get things sorted in 6 months. I know people who have been struggling for last 2 years also. So it's about 18 to 20 hours of work that we suggest every week. That should do it for you in 6 months. Okay. Uh,
Yeah, that's the more right
Christian
answer.
Christian Dial says best game genre for capstone. How about a capstone project in data in gaming industry?
So you would should explore the F2P game, free to play game, as more data is available on the Kaggle as well. So you don't have a struggle finding the data itself. So explore more F2P game. There are lots of bunch of data available for Dota. PUBG, you can find that data on their own website, which is through the PUBG API or on the Kaggle website itself. But I would advise to go with the F2P games only.
All right. All right. Vihan says, I'm a recent graduate in Australia. Do you have any tips for developers looking to join gaming industry? Should we focus on learning engines like Unity, Unreal, or focus more on the basics? So this is again something that comes a lot, to us also. Do they need to learn all these engines also? Unreal, Unity, all that stuff.
Oh, so yeah, if you're really looking into career in development, so gaming development, you need to have a very good hold about the Unreal or Unity engines. So Unity has this revision on its prices and on its products a couple of days back. I guess it's last week only where they introduced major changes in their products. So, but for the gaming data career as such, you don't need to learn any gaming development engines. You just need to have a good GitHub rapport with yourself so you can automate the gaming engines on GitHub only. So there are these cool features on GitHub, which is the workflows, which should be enough for any data scientist or data analyst to break through into the gaming career.
All right. Quantum computing, does that play a role over there in gaming industry?
So not really, but yeah, there's a different aspect to this. If you are looking for an profiling, like if you want to profile your game to work on low-end devices, medium-end devices, high-end devices, there needs a profiler in place. For that, you need to have an quantum computing basic knowledge in place, but you don't need an advanced knowledge about quantum computing. It's not at all required.
Can you give tips for a beginner who wants to pursue data science in general? Well, Aaron, I would rather suggest that you get in touch with us. Okay. We primarily, when you say basic, there are multiple aspects to it. What background do you come from? Is it mathematical, non-mathematical, programming, non-programming? So in order to give you a concrete answer, not a generic one, it's rather suggested that we get to talk to each other, and then it would be better. Yes, you can add your certificates to LinkedIn. What are
Yeah.
some of the common ways player segmentation is used in game data science? Kai
So
asked us.
players, yeah. So Kai, player segmentation has a different, actually a different cohort to it. Player segment in a retention, you can more look into its trending pattern. So low end paying customer, average end paying customer, or a high end paying customer, which we actually term it as whales or sharks. So if you are looking into retention data, these are the segments. If you are looking into gaming data and how the player actually plays the game, it could be is he a competitive player? Is he an average player? Is he a low end player? So it actually depends on the type of problem you're trying to solve. But yeah, player segmentation has a different caskets around it also.
Okay. Joseph says, can you give us the basic? We need to be a game developer. What do we need to focus on? Game developer and game data scientist. Is there, anything that is common in both these, or it's totally separate? How does that work?
So these two terms are the totally separate terms. So game developers actually implements the game in place. As a data science professional, you need to be in sync up with the game designers as well and game developers as well. Because developers can create a game, but actually data people are the one who is validating those claims turned into reality. A game, how would you term if a game is working smooth, if a working good or not? You need to analyze those development patterns, you need to analyze the codes, and then give that head start, whether it is a good game, whether it needs optimization, whether it needs scaling. That's it. But these two terms so far has been a complete different term.
Okay. Another question is, when should I use NoSQL for storing game data? I haven't found a use case for it so far. I end up using RDBMS.
So NoSQL, you could find this use case with the PUBG data only. So if you could call the PUBG API data, if you have really worked with the telemetry data and the NoSQL databases as well. So PUBG really stores their data as a document, which is the NoSQL format. Because NoSQL databases are used where schemas are dynamic, where they are ought to change. In industries where you know that schema won't change, your data parameters won't change, and they would remain stagnant over time as well, you choose RDBMS. The reason behind is you don't need to edit your tables so frequently that data gets corrupted, that data has no meaning behind it. So you use an RDBMS format where database schema would be stagnant, where it would be static. NoSQL would be used where database schema would be dynamic. Yeah.
Okay. I'm a professional in computer programming, but it's not even a question. Just 1 minute. Last question for me, is Python good for data science? Can you recommend? Do you use Python, Onkar?
Yeah, pretty very much. Actually, Python has that very cool libraries around it.
And what about
Pygame.
R? There's another question coming in. You can add it also. Is R still relevant?
So Sanket might be knowing there's a big fight in Python and R in data science domain. So
You can
personally,
probably make a game out of it, I guess.
yeah. So Python is actually the most used one, but R is nonetheless the lesser tool to use. R was specially developed by the statisticians to use for statistical purposes. So to gather any insight on statistics, to do any statistical analysis, there's no comparison to R. But if you're looking upon the flexibility, like Python can do web development, Python can do data analysis, it can deal with algorithms, it can deal with AI, so it can
Yep.
create APIs, it can call anything. So it is too flexible. You
That is
can do
also something
anything
that we
Python around.
recommend. That is also something we recommend. Another question is from Jesler, that is about generative AI.
Mhm.
So, with generative AI being disruptive in the number of industries, will generative AI also be significant change how gaming data science industry works, like ChatGPT, Bard being tools for someone working in data science?
So it won't be technically as possible for an generative AI in near future to replace the game data scientist or game data analyst. It can just enhance their workflows. For example, a generative AI can scan your code. It cannot write that 100% accurate code. That model is still a bit far from us, but it can help you to automate your processes like automation, like creating pipelines from your databases to actual Python environment, creating a short scripts to validate your game features. So you can actually command AI. Don't be a slave of the AI. Just command that AI.
Awesome. All right. Katya says, thank you so much for tonight's session. I really enjoyed it. Well, we enjoyed interacting with all of you also. And it was really nice connecting with all of you also. Thank you.